All right, in this lesson here, what we're going to be doing is talking about functions. Now, it's time to make everything interesting. We've spent a lot of time in the last VTM and this VTM talking about variables in different aspects, in one way or the other. But now it's time for some functionality, how we can take some code and kind of put in little modules, little functioning blocks, if you will.
Thinking cubes.
Yeah, that's interesting. Yeah. So basically throughout this lesson, what we're going to be doing first is talking about what functions are, and then we'll take a look at the syntax and some groovy examples. We'll talk about parameters and default values, function overloading, returning values, parameter referencing. A lot of fun stuff lined up.
Yes, there is. Lots of cool stuff.
Joel, show us what you got.
All right. So the first thing, what is a function? Well, like we already kind of touched on, function is basically a group of code that does one specific action, and you can reuse it over and over again.
That's right.
Would you like to add something to that?
It's one concept. I want to make sure that gets stressed because functions do pretty much one thing.
Right. Or at least you want to try to make it so that your functions do one specific task. You don't want it to do 30,000 different things because that would kind of defeat the purpose of a function.
Yeah, a function is there so that we can reuse code.
Right.
So we can write once and use 10 times.
Yeah, so like maybe find the length of a string or something like that.
That's right. Yep.
We can use it again and again wherever we want to.
That's right.
So, the first thing, syntax. How do we declare this great almighty function? First thing, let's say we want to create a function called printString, which is just going to print out hello world. That just has to be there.
So it would have been like we were doing before in our main block, which was like cout.
I mean, like we have in our main block, we had cout, hello world. Like that. Well, we're going to put this function in a... No, I'm sorry. This line of code in a function. Thank you. Yeah, that's what I meant to say. I really did. So on top of here, there's 3 parts of a function definition. The return argument, the name of the function, and then the argument
list.
Argument list. So in this case, we're just going to say void. Void means we're not going to have any return arguments.
That's right.
We're not going to return anything.
It is void of value.
Yes. And we're going to call this guy printString. Then we have parentheses, just like our main function. This is a function, void main.
Which we don't call the computer.
The computer basically calls it for us.
Yeah.
So inside of here, we're going to put void as well.
So we're going to have void. We're going to be void of parameters.
Right. We're not going to have any parameters.
Okay.
So to start a function, just like we do with main, we end it off with opening and closing braces. So inside of here, we can place a chunk of code that does a certain function, and inside of main, or any other function for that matter, we can call this one printString function.
Okay, so how do we do that?
How do we call it? Inside of our main, well, let's just cut this out. No, that's not what I meant to do. Let's just copy this guy and paste it inside of here. Now, printString is going to print out hello world. Now, main, when we start out, it starts top down and just goes line by line, doing its thing.
So if we ran this right now...
Nothing would happen.
Nothing would happen.
Nothing would happen. We can compile this and just go ahead and run it. Look at that. Just says press any key to continue.
That's awfully boring.
Yeah, that is awfully boring. We don't want that. That's bad. So inside of main, we want to print out hello world. So we need to call the printString function. So all we need to do is type out the name, printString, followed by empty parentheses because, well, we don't have any arguments.
And that's important.
That is important. So we say printString, empty parentheses, followed by a semicolon. If we directly run this, check it out. Hello world.
I like that. That's much more interesting.
Yeah, a lot more interesting. Now, I'm a debugger guy, so I'm going to put a breakpoint in here just to show you guys the flow of it. But first, I'm going to say cout before function call. And no. And then after function call. And then inside, I'll say...
In the function call. During the function call.
Function call.
So this is so we can find out how the program is flowing.
How the program is flowing.
And where we enter and leave and come back.
Yeah. So we start out with before function call. We go into printString when we get to line 14 here. So we go up to here. Then we run line 7 that says in function call. Then we print out hello world. Then when we get to here, it says, well, I got to go back to where I started.
Yeah, because we've ended our function.
We have ended our function. So we go back down to here and resume on the next line, which is after function call.
Okay.
So that makes sense.
Is that making sense, Buzz the student?
It does, and
I'll debug in a second.
I will, yeah, and I know you're going to do that. That's why I'm not saying much, because I do know that a lot of newbies out there in the world of programming, function calls seem to really confuse them in regards to, like, we're executing this line, then suddenly we make a call, so we jump to some other location and we do this and this, especially when you start having function calls within functions. And beginners seem to have a hard time as to where we at. Well, I'm lost. But right now, I think you're doing a great job with putting the C-outs in there. That made me really happy when I saw that.
Yeah, I thought it would.
And the debugging, I know you're going to do that, because if you don't, I'm going to pop you on the back and say, would you debug it?
Yeah, I know. So let's just run this quick just to show you. Notice it says before function call. Now
which means we're in main still.
We're in main. Then we say in function call, which means we're now in the print string. We print out hello world after function call, which means we're back inside of main.
We've already returned back to main.
Exactly. So then we're at the end of the program. So let's press any key to continue, and now let's place a breakpoint right here. Press F5 to start debugging. So we start out at the top of main, well, line 13, which is basically the top of main. And we say, all right, execute this line. Dink. So now we're at line 14. Now if we press F11, we're going to go into this function.
So we should jump to line 7.
We should jump to line 7. Dink. Or line 6.
Or line 6.
Yeah,
I guess that's the start of the function.
Right. So line 7, it says cout in function call. So we print this out. Now we're going to print out hello world. Now we've gotten to the end. So what's it going to do? Go back to the next line after the function call. Dink. So now we're back to cout after function call.
That's right.
Everything's cool, right? So we're done. Now it's the end of the program. It exits out. So everything's good. So that's basically all there is to a simple function. But there's all sorts of cool things that we can do with functions. We can pass arguments. We can return stuff. All sorts of cool stuff. So how do we pass stuff to it? Let's delete this. Well, actually, you know what? There's one other thing that is kind of important. We have this function call up here. If I took this and put it after main, Dan, what would happen?
Right now, I would say the system will say, hey, wait a second, buddy. What the heck is print string?
Right. It will say, identifier not found, even with argument-dependent lookup. Ooh, that means it's not there. What do we need at the top here?
We need a declaration of the function.
A declaration of the function, just so when the compiler goes through here and looks at everything and the linker does its thing, it knows where to look for it.
Yeah.
Basically.
I'm trying to think of an example here. Could it be like a name tag?
I guess so.
Where you have a name tag that will tell you who's going to be at the convention.
Right.
And then you can slap that name tag on, and then you know who it is who's at the convention.
Right. Before the convention happens, the name tags are given out.
That's right.
And then when you get to the convention, everyone knows who everyone else is.
That's right.
So, yeah, that is basically it. I never really thought about it that way.
Me neither, until just now.
All right. So all we need to do, it's exactly the same as the first line of the function, except you have a semicolon at the end. So print string, void, semicolon. So now the compiler knows that it exists. So we can say, compile this. Look, everything's happy. Isn't that nice? So now, where was I? Arguments. That's where I was, right?
Yep.
Sounds good.
All right. So inside of here, what we're going to do is...
Again. I'm just keeping you from jumping more advanced, again, from a beginner's point of view.
Okay.
We just might want to spend just half a second. I mean, this is so obvious, but again, to somebody, let's pick on Angela.
All right.
Like Angela. They need to understand the concept of basically how we have this stack that's keeping track of where we're at.
Mm-hmm.
So if we were to put another function in there and then make a call from inside print string, for whatever reason, to the other function,
right, that
we then return back to print string after that. And then finally, when that function's done, then we return back to main. Again, it's an area that I see people become confused.
So would you like me to create another function and then call them?
Yeah, you want to do it real quick?
All right, cool. So we can have simple func. All right?
Sounds good.
And we'll continue to do void because we haven't talked about argument list yet because you stopped me.
That's all good.
So inside of here, we'll just say void, simple func, void. And what do we want to do inside of here? How about cout, we're inside simple func. How's that?
Sounds good.
So something like that. Now inside of print string, we're going to call at the end simple, just like we did up here in main, print string, semicolon. We'll say simple func, empty parentheses, opening and closing with a semicolon.
Right.
So now what's going to happen, it's going to start here.
Which will print out
before function call. Go to print string, which will bring us into print string.
Which would be line 21 in this case.
Line
which
21.
Would jump us down then to line 22.
Line 22. And it'll say in function call, Then when it gets to line 23, it will say hello world. Then it'll jump down to line 25, and it'll say simple func, which will bring us into line 16, which is the inside of simple func. And it'll say cout, we're inside simple func.
And then we get to the end of the function.
End of 18, right? The end of the function.
And then we return back to who called us.
Yeah,
to who called us, which is print string.
Which is print string.
Exactly.
And then we get to here, which is line 26. We're at the end of this function, which means we now need to return all the way back
to the person who called.
Who called print string.
Print string.
Right.
So now we're at cout after function call. That's it. So if you look at this, let's just run this. So let me just move this out of the way so you can look at the idea we have here. Before function call, gets inside of here. In function call, prints out hello world. Then we call simple func, which goes inside of simple func, prints out we're inside simple func. We go out of simple func, dink, back into print string. Add at the end of this, so we go back to main, and we print out after function call.
Yep.
So that's cool?
Yep. Very good.
All right, so let's delete this now. Everyone's probably crystal clear at the moment. If you're not, oh well. Anyway, we can come in here. Now let's show you how to use arguments. So
we're gonna start this off slowly.
Slowly.
Very slowly.
Very slowly. So first, this is where arguments are placed. So we can say char, and we're just going to say simply think str. All right.
Now everyone should realize that as being just a variable declaration.
Right.
It's a variable pointer declaration.
It's just a variable declaration.
And even more important, as we just see a variable an argument is just a variable, but why do we have to have arguments?
Well, what if you want, since each function is its own self-contained unit.
There you go.
Sometimes you need to pass that function certain things that you may need to do. Let's say with our string length function, we want to find the length of a certain string. Well, the function won't know what string to work with to find the length of it.
Does that allow us to talk just a little bit about the word scope?
Yes, just a little bit. We probably did a little bit in the first
Just a little bit, but now we can tie it in with functions.
Right. Okay, so another tangent. If we come in here inside of main and say int j, alright? And we'll give this a value of 5. If we now come over into print string, this is a separate function.
Yes. Right? It's like its own little box.
It's its own little box.
Which has a lid on it.
Yep.
It's in the dark.
That's right. It's not aware of what's going on outside.
That's right. So if we come in here and say cout j, someone's going to cry. Someone's going to say that's not going to work.
I think the compiler is going to cry.
Yeah. Look at this. Bink, error. Well, that's a small. Let me just change this back. I'm sorry about that.
Yeah, that's actually that's important because you have to match your arguments.
Yes, your arguments have to be
in
the same.
both sections. And if you don't, you're going to get that error C2660.
Yeah, and that's a bad thing. So let's recompile that guy, and you'll notice J, undeclared identifier. Why? It's defined up here. Why can't I use it?
It's outside our box.
That's right. It's outside. It's not supposed to be usable by us. So this is considered a local variable, something that's local to the function. Right.
Right.
If I came in here and I defined int j equals 3, it's going to define j, and so when I cout j, it's not going to print 5.
No,
it's going to print 3.
We have our own j in the box.
That's right.
We have our j in the box, and we have a j outside the box.
Yeah.
And since we have our lid on the box, we can only see our j.
Exactly. So if we try to compile this, everyone's now happy except for the fact that we're calling simple func, which now doesn't exist.
Oh, yeah, that's also very important.
Yes.
Yeah.
If a function doesn't exist, you can't call it. Can't imagine why. So, that works. Check it out. It prints the value 3.
Which is what we expected.
Exactly. Because
that's its own local J.
Yeah, exactly.
Its own thing, yeah.
Yep. See, I say exactly.
But if we want to, we could go up to main, and we could also go ahead and cout J as well, just to show that we haven't changed J.
Right. Well, I'll
after
cout
our
it
function call.
Here.
Okay.
And then
again
after,
yeah,
I can print J again.
Just so we can show you that J's not been repopulated with 3.
So 5 before function call, in function call, hello world, and then it's
3,
still 5.
and then it's still 5 at the end. Very good.
So everything's cool.
My apologies for sending you off on a tangent. I just, again, in the explanation of functions for people, especially when you get into arguments, I think
that's right.
That's
it's kind of important, right? Actually, it's very important. Alrighty.
So this brings us into the need of arguments.
That's right. We need to get data to those functions.
Bingo.
We need to, in a sense, punch holes in our box so that we can put some
some
sort of
windows.
value into our box, into our world.
We can now throw stuff through the window into the box.
So let's just kind of delete out this extra stuff that we threw in here. Right there. Dink. All right. So, back to arguments. Inside of here, this is our argument list. We can have multiple argument lists if we want to.
We can have more than one. We can have none. We can have more than one.
Yep, exactly. So inside of here, we can say char str pointer. So that's going to hold a string. So if we need, of course, as we were saying before, these two need to now match.
They need to match.
So this guy right here has to be the same here without the semicolon.
And what Joel just did is actually probably the easiest way to make sure that your parameters match, which is a copy and paste.
Yeah, it works for me.
Just make sure that the semicolon is removed.
That's right.
When you actually define your function.
That is important.
That is important.
If you compile this, you'll notice print string function does not take 0 arguments. Now, when we call it, it's looking for an argument list. It's looking for a string.
Which we have to
pass to
it when we call the function.
So what we can do is say maybe call this buzz. So now we're passing to this print string function the string buzz. That's cool.
That's great. So inside our box, we now understand what str is.
Yeah, exactly.
And it's a array, essentially, that holds the values buzz.
So inside of here, we can say hello, instead of hello world, we can just change this to hello str, which in our case is going to be buzz. That works.
Nice, yeah.
I'm just going to delete these. Do you guys want this to stay here?
Yeah, no, you go and delete them out and start cleaning it up.
So we can delete that out. Now if we compile this, dink, everything's cool. So if we run it, check it out. Hello buzz. Now, I'm the kind of guy that likes debugging, so I'm going to go in here and just debug it really quick. Now look, we're at the first line inside of main. It says print string buzz. So we're passing the variable, the string buzz, over. And you know what? Let's delete all these things we have in our watch window from the last lessons. So we have print string buzz, and this is going to be passed to this function here. So we go inside. Now we're inside of this print string function. And if we look at str, let's actually put that down in the watch window. Dink, str is now buzz.
Buzz.
And if we print it out, we get exactly what we expected. Hello buzz. So that is right. Now, here's the thing that may be a little bit confusing to some people. What if we have another print string function? And this time I'll say Joel. Just to make sure that you understand that every time it's different. You can pass it anything you want to.
As long as it's a character string.
Exactly. If I put in something that it can't use, it's going to complain to me.
That's right, because your arguments have to match. The variables you send have to match your arguments.
That's right.
And it has to match in order.
Yes, it does. So if we come in here, press Control F5, look at that. It says hello buzz and hello Joel. So we can pass different data into that function so that we can use it.
So we've encapsulated the idea of printing a string, but we've given it flexibility.
That's right.
So we can change it every time if we need to.
That's right. And most of the time when your functions are going to have some sort of argument so that you can pass data to and from, or whatever, certain areas.
That's right.
So, with that, that's cool. Now, I want to write a simple function that I've been talking about for quite a bit, is the string length. So this encapsulates yet another kind of interesting thing. This is a return argument. So, what if we want to give back? Right now, we're giving the function something. But what if you want to give the
you want to give something back to who
the caller.
Called you.
That's right. So that's where return arguments come in handy. The return argument is placed right where this void is, right here. Right here. Exactly.
And the type of valid returns would be an int,
a float, pretty much any data type.
A character pointer. You can do pointer returns too. Or if we made a structure,
you go
ahead and return a structure.
Or even classes when we get to that.
Yeah, but we're not there yet.
We're not there yet. All right, I'm trying not to jump ahead. So here we are. Int. In other words, it's going to return an integer. And it's going to be string length. That's the function name. What do we need to pass to string length?
Well, if we need some information from the outside world, we're going to have to punch a hole or make a window in our box, which means we have to pass an argument.
And in this case, it's going to be
a character string.
A character string. So int string length with a character string. So let's copy this over here, and put it down here. Now we can define this string length function. So what do we need to do? First thing, let's define a local variable called length so that we can store the length of our string. Then what do we need?
Well, I have a feeling that what we're going to do is take advantage of how strings are stored inside of C.
Right.
And strings are stored as we would an array. They have indexes, 0, 1, 2, 3.
Yep.
And at the end of that, list of values, there's a \0,
which is a null character,
or a null character.
Right.
And what we can do is we can search for that character.
And when we reach it, we know that we're at the end of the string.
That's right. And then we have our length calculated.
So we can come in here and say, while the str of the current length. Well, here's another thing. We need to first define length as 0.
That's
Otherwise, we're gonna,
Back in school, I learned this as sort of priming the pump.
Right.
We're going to seed some values so that we can actually use them inside of our loop.
Yep. We've got to get everything set up. So inside of here, we can say, while str length does not equal \0, which is our null character.
Our null character.
And that off. Inside of here, we'll just say length ++, which means we're going to move to the next character inside of our string.
Yep. So let's say, just for example, like my name is Dan.
Right.
So it's D-A-N.
Right.
Inside of C, that would be represented as a string D-A-N, and then the null character, \0. So when we go through this, we'll start with length 0. We'll look at string at index 0, which is D. It's not the null character.
Yeah.
So we can add 1. Then it'll be A. Then it'll be N. And then we'll find the null character.
Right.
So our length will be 3.
Yep.
Because we'll jump out of the while loop.
Right, so all we need to do now, if you want to pass back, as we were talking before, we simply say return length. So now we're returning back to the caller the variable length.
And that's important. The return is the keyword that will tell the compiler what
to give it back.
What we're giving back. But the big important part is that length could actually be any variable name you want.
Yes.
It just has to be defined inside of the function.
That's right. It has to be something that this function can see, even maybe a global variable, but I wouldn't do that.
No. That's not sort of modern programming standards.
No, it's not.
Variables.
So inside of here, how do we call it? Just like we did before, we can say string length, and let's use your example, Dan. So however, we are returning a value to the caller, so we can say int str_len, so the string length, equals string length of Dan.
So this would almost be, when we run this, int string length equals 3.
Yep.
It's the same. It's identical, except at runtime we can feed any string in, and depending upon how long the string is, we will get a different value.
Exactly. So we can print this out and say cout. Dan is let's just print it out. String length, like something like that. And let's just remove these two just for now, because we kind of get the idea for those things. Right. So let's compile that. Let's run it. Dink 3. If we change this to say Danielle, that should be what? 6. Dink. 6. It is now 6. Now, just one quick thing. Again, I think this debugging might help. Do you get it, or would you like a debug?
Well, debugging is always cool.
I think debugging is cool. So let's come in here, and let's run it through. All right. Let's step into the function, because at this point, string length doesn't know what's supposed to be in it, because string length, the function, has to pass it back.
That's right.
So let's step into the function just by pressing F11. And we start out by saying, well, let's put length in here. So length is currently undefined. So let's define it and set it to 0. Now, what is in str length? Str bracket length at index 0. D. So D does not equal 0. That means we should continue going.
That's right.
So dink length +1. So now we're up to A. A does not equal that. Continue with the while loop. Length ++. It is now N. So that's not equal to 0. Go to the next one. ++. Well, now it is equal to 0. Notice, this is equal to 0 down here. So, while, do not continue. So now we have this length 3, which is DAN, 3. Return this back. And now at this point, it knows what has been returned, so it now needs to set that into str_len. Think. Now it is set. If you look over in locals over here, you'll notice str_len is set to the value 3. So everything's perfect, just the way we wanted it. So that's really cool.
I just want to point out, although this doesn't make the idea work as we're putting it, you do not have to assign a function that has a return value. You can. It's quite valid to call string length Dan and not assign a variable value, its value to a variable.
Right.
But if you think about it, that doesn't
make a whole lot of sense
to do it. But I just wanted to put it forth that if for some reason you're not getting the return values you want, it's probably because it's not being assigned to anything.
Right. I mean, if you just... what you're saying is just doing that.
Yeah, you can do that.
You can do that, and it's not going to complain. It's just like, well...
Well, actually, I guess it did complain.
Well, we didn't define STR.
Oh, that's true. That's
so
true.
let's just kind of comment that out for a second. And you'll notice it's very happy with that.
That's true.
It's not going to be upset.
We could directly see out that, too.
Yeah, we could just go in here and say see out, string length, and we don't need to put it in a variable if we don't want to. It'll directly send it out, and it'll work fine.
Because it's returning the value 3 in this example.
Right. Now, I know that's a long thing, but we've got some more stuff that's kind of interesting and kind of useful when you're dealing with functions, and that is passing multiple arguments to these things. So let's say right here with our print string, what if we wanted to print out 2 strings at once and it just separated by a space? Well, we can do that. We can come in here and say car str1, and then the second one can just be str2. Every argument,
I'm sorry. No,
is separated by a comma.
That's right.
Every argument is simply separated by a comma. This could go on forever. Well, just about. You can do another one, str3, if you wanted to. Dong, just as many as you want.
You want to make sure that each variable name is different, though. It's just like any other normal variable.
That's right. That is an important thing. So if we wanted to print this out, this is hard. str1. Let's put a space in between, and let's just print out str2. Ooh, fancy.
But we're going to have some problems. Oh, we're not going to have some problems.
The reason is because we're not actually calling it, so it doesn't know. So what we want to do is come in here, and let's just say print string, and we'll pass it 2 things, my first name and my last name. So now it should print out Joel space Van Enwyck. That only makes sense.
But our function definition
isn't
not
right.
updated.
It only has 1 argument.
That's right.
So if we compile this, dink, print string function does not take 2 arguments. It thinks it only takes 1. But our definition down here is taking 2.
We just need to make them match.
Yes, we need to make them match. So we could copy it, or we can just come in here and say dink 2. And let's compile this guy, run it, and look at that. Joel Van Enwyck. And it prints out 3 because of our Dan. And that's it. That's all there is to it. Now, all of that. There's one more useful thing that we need to talk about.
Hang in there, people, because this is something that will come to play in the classes section.
Oh, yes, big time. And that is references. Well, reference arguments.
Reference arguments.
Right. So if we come down here, let's change our string length function a little bit. Let's say, for instance, let's come in here, and let's say int strlen, alright? But instead of having the string length function return to us the variable, we can simply go string length, and we can say Dan. We'll pass it strlen. So what we want to do is have this string length function change the value inside of strlen, so that when this function is finished, we can use strlen and know the exact length of Dan.
Okay. So we're going to have to change our function definition then.
Yes, we will. What we're going to do is come into here, press comma, so we're going to add another argument, and this is going to be an integer. But instead of just putting out an integer like strlen, that wouldn't work, because this is what is called passed by value.
It's kind of a one-way street.
Yes, it is.
You can only throw it into the window, and it's never really going to be bounced back outside of the window.
That's right.
Just a copy of the data.
Just a copy of the data.
Right. So what we need to do is change this to an ampersand. Now what this is going to do is this is a reference argument. So if we change strlen inside of the function, it is going to actually change strlen inside of the caller that was passed to us.
So it's kind of in a way like a simplified pointer.
Yes, it is. It just makes it so you don't have to deal with the asterisks and all that stuff.
That sounds very nice to me.
Yes, it is nice. So let's take this, copy it, and put it in here. Now, it's not going to be hard to change this. All we need to do is say strlen equals length. That's all there is to it, because we're allowed to change strlen, and it will change the caller's strlen. Of course, these 2 arguments can be named anything. It doesn't matter.
So why don't we just go ahead and do that?
Do what?
Just change the name.
Just
to emphasize that point. Thing. And then we'll have to change it in the function. And the header won't actually matter.
The header doesn't actually matter. This actually brings up another thing. If I wanted to, I could just go ahead and delete this altogether and delete that. You don't really need to specify a name. I typically do just because it makes the top part here more understandable.
That's true. Because what if you had 5 care pointers in a row?
Right.
You'd get a little confused.
Yeah, it would be confusing. So let's just put that back in there. And let's compile this guy. Now, of course, we're going to have a little bit of problem here because, well, we just changed string length. So let's delete this cout out. Come up here and print out strlen. So this should print out 3, as it did before.
It should, because it's going to reassign strlen to have the value of 3, and that will be printed out.
Yep. Of course, we have a little bit of problem here.
Oh, you have a semicolon. Remember?
Yes, I do.
The very sneaky semicolon. It can throw you every once in a while.
It bit me in the butt. So let's compile this guy. So everything's cool.
That's great.
So if we run this, Joel Van Enwick, and it prints out 3, which is right. Now here's the thing. I kind of want to drive this home a little bit. What if I was to change and take away this ampersand?
Ooh, well, then you wouldn't be passing by reference.
No, I wouldn't. I would be passing by value, which is a copy, like Buzz said. So if we delete this, let's recompile this. Now if we run it, look at that. We get an error.
I don't like errors.
No, I don't like errors either. And the reason for that, let's run through this just so you can see it. Dink. And let's push play on this guy. Now let's F10. Now, when we're passing string length, Dan, and we're passing the string Dan, and string len, this is a undefined value because we haven't defined it yet. So let's go inside of our function, and look at that. String length is being used without being defined. That's a problem. And it's good that it caught it, because that is helpful to us. So let's break, and let's just stop debugging for a second. Let's go in here and say string length equals 0. So that should make it happy. But this is not going to fix our problem of it not changing that variable. If we come in here, look, Joel Van Enwick, it's still 0. Why is that? Well, if we come in here, I'm going to debug again. No, I'm jumping around a little bit, but I think it should make sense.
This gets back to the idea of scope that we talked about earlier. It's only going to be visible in the function main.
Right.
And although we will understand what thing is inside of string len,
right,
it's not going to reference string len.
That's right. So if we come in here and say string length Dan strlen, let's go into the function. Thing is 0. That is right. So we come in here, we loop through. Look, length is 3. And we even go ahead and say thing equals length. But we're changing the copy. We're not actually changing the variable that's inside of our main function. So when we return and go back, strlen is still going to be 0, no matter what. So that is how we can do it. But see, here is where the whole pointer thing does come into play. Because we could do that entire thing of the whole reference argument with pointers.
It's true.
Yes, we can. And I'm going to do it, just to make you happy.
Okay.
So let's come in here and change this to a little star thing.
So now we have a parameter that is an integer pointer.
Right. And we're going to have to change it down here into pointer thing.
And then we're going to have to change how we use it in the code at line 25.
That's right.
Because we have to...
Thing is now an address.
Reference it.
So we now have to reference it. So let's put a star into it. That should be it, right?
Which is now saying we're going to assign the value to the variable that is located at the memory address.
Right.
Yes. I hope I said that correctly.
I think you did, yes. So inside star thing equals length. Now, it's not going to work, and I'll show you why. Dink. String length cannot convert parameter 2 from int to int pointer.
Well, is this something to do with how we were dereferencing variables before?
Yes.
Because we had to pass a pointer.
We have to pass a pointer. At this point, we're just passing the value 0, which, well, 0 isn't exactly a valid address in our case.
No, not for memory.
No.
And pointers deal with
memory. Exactly. So what we need to do is...
Little ampersand.
Ampersand. Dink. Hey, Buzz, your wig.
Hey, how's it going?
So we can say ampersand strlen, so that's going to pass the address.
That's right.
Now, let's just run it first to prove that it does in fact work. Dink. Now it's 3. Everything's happy. Let's debug. Dink. Dink. So strlen is 0. Now, let's go into our watch here. And let's just delete these guys out. And let's say what is the address of strlen. 0012fed4. So let's go into this function. So it's passing this address right here into that function. Dink. So now we're in here.
So we're in string length.
We're in string length. Let's finish that. Now length is going to be, well, let's put that in here. Length is 3. Thing. What is thing?
Thing's a pointer.
Thing's a pointer.
It should be a memory address.
So 12fed4.
That was the same as it was before.
Same as it was before. Nice.
I like that.
Yeah, I like that too. If we press the plus sign here, you'll notice that the current value that thing points at is 0, which is what we defined. If we go back to main, strlen was declared as 0. So, now if we say star thing equals length, it's going to set this right here to 3. Dink, it is now 3, which does in fact change strlen to 3 as well. Dink, strlen is now, if I put it correctly, 3. strlen is 3. So everything's perfect. So let's stop debugging. Actually, you know what? That finally does cover everything. Yeah. It's a lot of stuff.
It's a lot of stuff, but this is something that you're just going to be dealing with constantly.
Yeah, I hope it isn't too confusing for people, but it sometimes is. It just has to be.
Yeah, and they can watch it over and over. That's the beauty of having this on video.
Oh, yeah.
So with that, that's going to wrap up the lesson on functions. Thanks a lot, everyone.